solving. First, we need to talk about what the four-step problem-solving process is. The first step is understanding the problem. We need to know what is being asked. The second step, devising a plan, is different ways to figure out the problem, the answers to the problem. Number 3 is carrying out the plan, and number 4 is looking back to make sure that the answer makes sense. So in this section, we concentrate on devising a plan. Okay, so the first one is we can look for a pattern. Let's look at this example. 1 cut through a log produces 2 pieces. 2 cuts through a log produces 3 pieces, and 3 cuts produces 4 pieces. How many pieces are produced if there are 10 cuts? How about n cuts? Well, one way we could look at this is we could see that there's a pattern. So we could say that the number of cuts versus the number of pieces. Okay, so we were told if there's 1 cut, there'd be 2 pieces. If there's 2 cuts, there'd be 3 pieces. If there are 3 cuts, there would be 4 pieces. So this looks like a pattern. The number of pieces seems to be 1 more than the number of cuts. So if I continue on and go to 10, and I continue in that pattern, I would get 11 pieces. So 10 cuts will give us 11 pieces. So then, in general, n cuts will give us n plus 1 more pieces. Okay, the next one is examine a related problem. So before we look at the problem we're going to talk about, we're going to talk about Gauss's problem. When Gauss is a mathematician. When he was in elementary school, his teacher thought that he would keep the students busy and ask them to find the sum of the first 100 natural numbers. But to his surprise, Gauss figured this out in just a couple of minutes. And this is what he did. He said, I'm going to start way over here, S is what he called the sum. Okay, and he said, well, 1 plus 2 plus 3 plus dot, 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 plus 100 is the sum of the first 100 natural numbers. Then he said, well, I'm going to write that out again, except I'm going to write it backwards this time. So 100 plus 99 plus 98 plus all the way down to 1. Then he added these two together. So S plus S would be 2S. And what he found was there's a pattern. Each one of these columns added up to 100 more. So he said 2S equals, and then he realized, well, since I was adding from 1 to 100, this happened 100 times. 100 times 1, because 101 came up 100 times. Multiply these gives us 10,100. And solving for S, we divide by 2. And he came up with the sum was 5,050. Okay, so we can use this as a related problem to find the next one. Find the sum of the odd natural numbers less than 100. So the difference this time is the word odd. Okay, we could start off the same way. S would be 1 plus 3 plus 5 plus all the way. The last odd number less than 100 would be 99. Reverse the order. 99, the next will be 97, then 95, all the way down to 1. add them, 2s. This time each column adds up to 100. Now we've got to figure out the number of times this happens. Now, since we're talking about all the odd numbers up to 100, that's half of the numbers. So if we went from 1 to 100, that would be 100 numbers. But we're only using half of those, so this happens 50 times. So 50 times 100. And then we continue as we did before. 50 times 100 is 5,000. Divide by 2. And our sum is 2,500. Okay, the next couple of problems we're going to look at, we're just going to really set up, and I'm going to show you how to figure out how many times something happens. Okay, so if you start at 1 and you go to 100 and you're talking about the odds or the evens, you're going to have half of that. However, sometimes we don't start at 1. So let's look at this one. Find the number of columns if the sum between 9 and 15 is asked for. Okay, so there's a couple of ways to do this. One, we could write it out. Be 9 plus 10 plus 11 plus 12 plus 13 plus 14 plus 15. And we could just figure out how many of these there are. And if you add them up, the number of columns will be 7. Okay, now there's another way to do this because we don't always want to list out all of the numbers. What we could do is the largest number minus the smallest. So here that would be 15 minus 9, which would give us 6. And that's actually 1 too small. You notice we got 7 over here. So we're going to add 1 to that. So it would be 15 minus 9 plus 1. Again, would give us 7. Okay, so the next one says, how about between 32 and 98? Here, we definitely would not want to list all of the numbers between 32 and 98. So we could follow this largest minus smallest plus 1. And when you do 98 minus 32 plus 1, you get 67. So the number of columns, the number of times you would get that repeated sum, would be 67. Okay, the third strategy is examine a simpler case. Okay, so here 16 people have entered into a tennis tournament where each player plays each player only once. How many games were played? Well, 16 is a lot of people, so we could start with something smaller. I'm going to start with 4 people. And just to make it easier, I'm going to call them person A, person B, person C, and person T. Okay, so we start off with person A. Okay, person A is going to play person B, person C, and person D. They end up playing 3 games. Then person B has already played A, so we need to figure out how many more games they're going to play. Sorry about that. They're going to play person C and person D. They're going to play 2 more games. Person C then has already played A, has already played B, only has 1 person left, person D. And then person D has already played everyone, so he doesn't have any more games left. So then we add these up. 3 plus 2 plus 1 would give me 6 games. Okay, we could do this again. This time, let's do a little bit bigger number and see if we could see some kind of pattern. Let's do 6 people. Okay, so we have person A, B, C, D, E, and F. Okay, so person A will play B, C, D, E, and F, and that would give us 5 games. Person B would then have left C, D, E, and F, which would give them 4 games. C would play D, E, and F, which would give them 3 games. And hopefully you're starting to see a pattern here. D would play E and then F, 2 games, and E would only have 1 game left. So we'd go 5 plus 4 plus 3 plus 2 plus 1, and that would give us 15 games. So we have kind of a pattern here, and that's that you start with the number that's 1 less than how many people you have, and then add straight down to 1. So for 16 people, we would start at 15 and add on down all the way to 1. Now there's a couple ways you could do this. You could just enter all of that into your calculator, or you could use Gauss's method that we used in the previous type problem. But either way, you'll get 120 games. Okay, the next strategy is to make a table. I'm big on making tables, and I like to make tables to look for patterns and just to see what I've got. So let's look at this one. Example, Anna and Brian start a new job on the same day. Anna is required to check in with her boss every 15 days, whereas Brian has to do the same every 18 days. How many days will it be before they both check in with their boss on the same day? So what we could do here is I'm going to make a table, and I'm going to do it horizontal just because I've got room that way. You could also do this vertically. Okay, but let's start with Anna. She has to meet with her boss every 15 days. So she meets with her boss on the 15th day, add 15, go 30, and keep adding 15 for a while. I'm going to stop there. We could always go back and add 15 more if we need to. Okay, then Brian meets his boss every 18 days. So 18 more will be 36, 18 more is 54. And what we're looking for is for the day that they both meet their boss. So if I keep going, I get to 90, and notice 90 is listed in both of their columns, or sorry, both of their rows. That means they both meet their boss on the 90th day. That's the first number that they have in common. Okay, so they're going to meet on the 90th day. Okay, the next one, identify a sub-goal. Sometimes your problem asks for a lot, and it might be easier to break it down into little pieces. So we have 5 friends decide to give a party and split the cost evenly among them. Catherine spent $4.75 on invitations. David spent $12 for soda and $5.25 on vegetables and dip. Elizabeth spent $24 on pizza, and Frank spent $6 on plates and napkins, and George spent $13 on decorations. Determine who owes who money and how it can be paid. Okay, so what we might want to do first, and I'm going to call these sub-goals, is find the total cost of the party. Okay, so you don't have to write these sub-goals out, but I'm writing them just so that we could see them. Okay, so to keep it short, I'm going to call it them Catherine is C, David is D, and so on, Elizabeth, Frank, and George. Okay, and I'm going to go through and make a chart, make a table. Told you I like to make tables. First one spent $4.75. David spent $12 and $5.25, so a total of $17.25. Elizabeth spent $24, Frank $6, and George $13. Okay, so if we find the total, we just add all this up, and we get that the party cost $65. Sub goal 2 would be to find out how much each should have paid. Okay, so what I mean by that is each person, let's see, there's a total of 65. I'm going to divide that by 5 because there's 5 people. So each person should have paid $13. Okay. So looking at this chart, George has already spent $13 exactly, so he doesn't owe anyone money. Our sub goal 3, find who owes who. Now there's lots of different ways this can be done. I'm going to start with just working at the top. Actually, I'm going to start with the whole numbers. Here I've got whole numbers. Okay, so Elizabeth has paid $24, so she paid too much, so she should get some money back, and she should get $11. Frank only paid $6, so he owes $7. So we could start with that Frank pays Elizabeth $7, and then Frank would be done. Okay. At that point, Elizabeth should still get $4 from somewhere. Okay, so let's see what happens up here. Catherine only paid $4.75, so she owes $8.25. Okay, and David paid too much, so he should still get $4.25. So David still should have $4.25 and Elizabeth should still get $4, and that happens to add up to exactly what Catherine owes, so she could pay both of them. So Catherine would pay David $4.25, and then Catherine would pay Elizabeth $4. The next one's make a diagram. Draw a picture. An elevator stopped at the middle floor of a building. It then moved up 5 floors, stopped, moved down 7 floors, stopped, and then up 9 floors and stopped. The elevator was now 6 floors from the top. How many floors does the building have? Okay, so we have this big tall building. We start in the middle. Okay, so the first thing it does, it moves up 5 floors. Then it moves down 7. That means it's going to go past the middle floor. Okay, it's going to be below by 2. Then it goes up 9. Okay, so we know is already down below by 2. From here to here was 2, which leaves this to be 7 floors. Then it says it's still 6 floors from the top. So these two added together give 13 floors. Okay, since this is the middle floor, that means that there are 13 floors below also. So then to get our total, most people will say the answer is 26, but be very careful because we have 13 floors above the middle floor, 13 floors below the middle floor, and the middle floor. So that gives a total of 27 floors. Okay, the next one is called using the guess and check method. And a lot of times we use this when we're just not sure. Again, we just play with numbers to find what works. So a group of students is building a sailboat. The students have 64 square feet of material to make the sail. The sail will be in the shape of a right triangle where the height is twice as long as the base. What are the lengths of the height and the base? Okay, so first of all, here's the picture of our sail. It's a right triangle. And we're told the height is 2 times as big as the base. Now the area for a triangle is 1/2 base times height. Okay, so we start with, I'm going to make a chart. And we're going to make some guesses and see what works. Okay, so I'm going to start with 5. Let's say the base is 5 feet. Okay, then the height is supposed to be twice as long, so that'll be 10 feet. Then I'm going to plug it into this formula, 1/2 base times height. And when I do that, I get 25 square feet, which we want it to be 64 square feet, so that is too small. Okay, that means 5 was too small. So let's pick something bigger. Let's pick 10 feet. If the base was 10 feet, the height then would be twice as big, 20 feet. Plug that into our formula. And this time I get 100 square feet as my answer. And this one is too big. So that means that my base is somewhere between 5 feet and 10 feet. So I'm just going to pick a number between, let's say 8 feet. Then height would be 16 feet. 1/2 base times height. And this time I get 64 square feet, which is just right. I call this my Goldilocks and the 3 Bears problem because I have too small, too big, and then just right. So the dimensions are the base is 8 feet and the height is 16 feet. Okay, the next one is work backwards. Harriet has taken 11 tests and her average is an 80. Her instructor said her lowest score of 50 would be dropped and we need to figure out her new average. Okay, so first remember that to find an average, you take the sum of all the tests together and divide by the number of tests we have, which is 11. Okay, we don't know the sum of the tests, but we do know after this was done, the average was an 80. So we could figure out the sum of the tests by solving for this. So we're dividing it by 11. I'm going to multiply it by 11, same to both sides. Then the sum of the tests is 880. Then I got to find the new sum. After the 50 is dropped. So we do 880 minus 50. That would give me 830. Then I can find the new average by taking the new sum and dividing it this time by 10. Now the reason we're dividing by 10 is we had 11 tests, we dropped one, so now we only have 10. So I'd do 830 divided by 10 would give me an 83. And does this make sense? Yes. If you drop a lower grade, your grade should increase. Okay, so this is the end of section 1.1. I encourage you to pause the video and try the worksheet. I use these worksheets in class with my students to give them some practice. I will go over them in just a moment, so go ahead and pause it. Welcome back. Okay, so there are two problems on this worksheet. So the first one is find the sum using Gauss's method. So first I'm going to rewrite this first sum, just to get more room here. Okay, so Gauss's method, then we reverse the order. And right here we want to put a 7 because that was the first number. So it makes it a little bit different than the problems that we were doing earlier. Okay, add these up. So twice the sum. And if you add each one of those up, they end up being 152. Now we need to figure out the number of times this happens. We use all the numbers between 7 and 145. So remember, you go big minus small plus 1. That's going to give me 139. This happens 139 times. So twice the sum, 139 times 152. That gives me 21,128. Divide by 2, and I get 10,564. The second one, a hamburger and fries cost $5. If the hamburger costs 20 cents more than the fries, how much is the hamburger? So we can kind of use a guess and check. You could guess some numbers and see if they work. Remember that the cost between the hamburger and the fries has to be 20 cents. You could pick numbers and see if they add up to $5. Another way we could do it is we could play with the money. We could say, well, I have a total of $5. I'm going to divide that by 2. That gives me $2.50. So if they were the exact same cost, they would cost $2.50. However, there's a 20-cent difference between the two, okay? And so what I'm going to do is take that 20 cents and split it in half, okay? So if I do $2.50 minus half of that is 10 cents, would be $2.40. And then if I added the 10 cents, I get $2.60. And you see how they are 20 cents difference. So they're 20 cents difference, and they add up to $5. Now we just got to label which one is fries and which one is hamburgers. So this tells us that the hamburger costs more. And so that gives us our answer. Another way we could have done this problem is you can actually set up something called a of equations, so I'm going to show you that. We know hamburger plus fries is $5. And then we're told the hamburger is 20 cents more than fries. Then we can use what's called substitution. You have H equals, so we're going to plug that in for H. That's in for H. We still have plus F equals 5. Collect like terms. Subtract the 20 cents. Divide by 2. And you still get the fries cost $2.40. You come back over here then. You'll get that the hamburger costs $2.60. Now there are other ways to solve this problem. These are not the only ways, but you should get $2.40 for fries and $2.60 for hamburgers. This concludes section 1.1. You can now do the homework for this section. If you have any questions, feel free to email me and use the Ask My Instructor button so that I can see your exact problem.